Kinetic energy is energy of motion. The formula for kinetic energy is EK is equal to 1/2 times m times v squared, where, of course, energy is measured in joules, mass is measured in kilograms, and velocity is measured in meters per second. I should say, rather than velocity, this is speed, because there is no vector above it. The only thing that changes about this formula and how we use it is rearranging. What you should note is that we could also write it as EK is equal to mv squared divided by 2. It's the same thing as multiplying by 1/2. And that might help you to rearrange. If we're looking, for instance, for velocity, we need to multiply both sides by 2, and that'll cancel out the 1/2. We're left with 2 times EK is equal to mv squared. Again, we're looking for velocity, just as a practice. So we'll divide both sides by m. M's cancel. And I'm left with v squared is equal to 2 times EK all over m. To get rid of that square, we have to square root both sides. And when I square root the right side here, note that I square root this entire fraction. That will give me velocity is equal to 2 times EK all over m, all square rooted. Okay, that was just a quick reminder on how to rearrange an equation with a square in it. So let's try some examples here. Remember, when we are looking at physics, we want to divide our page into 3 sections. In our first section, we're going to list our information. Second section, we will write our formula and rearrange. And then third section, we will solve. So a car with a mass of 1,500 kilograms is moving at a speed of 50 kilometers an hour. What is the kinetic energy of the car? So listing what we know, we have the mass, and we have the speed. We're looking to solve for EK. I can't make my E's that way. Sorry, gotta go back to my old way. EK is our question mark. Noting here that we have the unit of kilometers per hour for our speed, but in our formula, we can only put it into the formula as meters per second. So we need to convert kilometers per hour into meters per second. So I'll do that first here. So 50 kilometers per 1 hour. There are kilometers go on the bottom and meters up top. There's 1,000 meters in 1 kilometer, and that will cancel our unit of kilometers. And in 1 hour, hours up top, I can go directly to seconds. There's 3,600 seconds in 1 hour. And remember, that is 60 times 60. Okay, when we finalize that, we get 13.89 meters per second for our speed. Now, because it's not my final answer, I don't care how many significant digits you write here. I wouldn't recommend writing every number in your calculator, but you can definitely use more than your final significant digits. Don't round too soon, okay? The formula we're going to use is simply EK is equal to 1/2 times mv squared. So solving for that, EK is equal to, I'm just going to quickly erase what we did over here, maybe to give myself some room. So EK is equal to 1/2 times our mass of 1,500 kilograms times our velocity in meters per second, which was 13.89 meters per second. And now we are going to square that number. This is different than the acceleration units of whatever number you had, meters per second squared. This square is applying to this whole number. It is not part of the unit. So we do need to square this in our calculator. So take a moment, enter that in your calculator. Again, don't forget the square. And I got 144,676. The unit of energy is joules. Now, in our question, we had 2 significant figures as the lowest number. So we need to report this number in 2 significant digits as well. The decimal is currently here, and when I write this in scientific notation, I have to, the decimal moves to between the 1 and the 4. So I need to move the decimal 1, 2, 3, 4, 5 times. Therefore, my final answer will be reported as 1.4. I don't need to round up. Times 10 to the 5 joules. Okay, let's try another one. The mass of a neutron is 1.67 times 10 to the negative 27 kilograms. If a neutron has 1.1 times 10 to the negative 14 joules of kinetic energy, what is the magnitude of its velocity? Get that out of the way. So we are going to list our information. We have the mass of a neutron, just a really small particle. Remember, those are found in the nucleus of our atoms. And we were given the kinetic energy of that neutron. So 1.1 times 10 to the negative 14 joules. And we are being asked to solve for velocity in this case. Units for mass and kinetic energy look good. So we are going to simply start rearranging our formula. So EK is equal to mv squared divided by 2. Remember that dividing by 2 is just the same as multiplying by half. To rearrange, I'm going to multiply both sides by 2, and that'll cancel this. And I'll divide both sides by m, canceling m. I'm left with v squared is equal to 2 times EK all over m. To solve for just velocity, we square root both sides, and we get that velocity is equal to the square root of 2EK all over m. All right, subbing in to our formula, speed is equal to the square root of 2 times 1.10, forgot my 0 there, times 10 to the negative 14 joules divided by 1.67 times 10 to the negative 27 kilograms. This is where brackets come in really handy and are very important. You must make sure that you put brackets around this in your calculator if you're actually writing times 10 to the hat negative 27. Otherwise, your calculator is going to do BEDMAS and you'll get this wrong. What I would do is multiply 2 by this number, press enter, and then divide by bracket 1.67 times 10 to the negative 27. Close your bracket, press enter again, and then square root that answer. In the end, I got an answer of 3.63 times 10 to the 6 meters per second. And I have already rounded that to 3 significant figures from my question. This is a ginormous answer, but it does make sense. So the speed of light is 3.0 times 10 to the 8. So this is about 100 times less than the speed of light. It makes sense because particles in atoms are traveling at a pretty fast rate. Okay, last question. Today's lesson is super short and sweet. Work is equivalent to energy. We remember this as work is equal to some sort of change in energy, whether you've gained potential energy, whether you have gained or lost kinetic energy, however you see. So work can create kinetic energy, but work can also remove a kinetic energy. So in this case, a driver of a 1,500 kilogram car traveling on a highway hits the brakes. A force of 12,000 newtons stops the car in a distance of 64 meters. How fast was the car going when the driver hit the brakes? So work was done by the brakes to slow the car down, to remove the kinetic energy. So we're going to use this idea that work is equal to some sort of change in energy. This would be the change in our kinetic energy to solve this question. So let's list what we know. We have the mass of the car is 1,500 kilograms, and there's some sort of force of 12,000 newtons, and we have a distance of 64 meters. Now remember that work is equal to force times distance. So we have some information there for work. So building off of work is equal to, this is probably a terrible color on the board. Let me back that up. Work is equal to energy. And specifically in this case, it was equal to the change in kinetic energy. We know that work was equal to force times distance, so I'm going to sub that formula in for work. So force times distance is equal to, well, I also know that kinetic energy is equal to 1/2 mv squared. So I'm going to sub that in for EK over here, 1/2 mv squared. So because work is equal to a change in energy, and in this case, we were losing kinetic energy due to the work of brakes, I can say that force times distance is equal to 1/2 mv squared. This will help me to solve for the speed of the car when the driver hit the brakes. So we need to solve for speed in this case. So I'm going to multiply both sides by 2 to cancel my 1/2. And I'm also going to divide both sides by mass. That leaves me with v squared, just switching sides here, is equal to 2 times force times distance all over mass. And to get v by itself, we are just going to square root. And we find that v is equal to the square root of 2 times force times distance all over mass. We have all of those pieces of information, so we can obviously solve this. So speed is equal to 2 times the force, 12,000 newtons, times 64 meters, divided by 1,500 kilograms. When you solve this, making sure that you multiply all the way across the top, divide by 1,500, and then square root that value, I ended up with 32 meters per second. And that was rounded to 2 significant figures because of the 64 meters. So that's the homework, that's the lesson for today. Again, short and sweet, just 3 examples there. Remembering how to rearrange this equation for all of the different variables, as well as equating work and energy. Take a look at the practice to make sure you have a strong grasp on this.